so when we are graphing, for the time being, I'm giving you the characteristics. Next week, you are responsible for finding these characteristics on your own before you even graph. These are like your guidelines. You want to know your asymptotes ahead of time. They help you guide where to place your points and determine the behavior of your graph. Okay, the mistake that you guys did on the quiz the other day, I already showed you, was remember the parentheses? Okay, what did I say about the parentheses if you have an outdated calculator?
You have to put,
When you try and put this in your calculator, where should you put parentheses? Around the numerator and around the denominator, because the calculator needs to know exactly what is in the numerator. Otherwise, it will read it as just this last number divided by this first number, and everything else seems like it's separated. You have to group together everything in the numerator. Okay, so let's start, before we even put this in our calculator, graphing the characteristics provided. How do I graph a vertical asymptote at x equals -1?
Go to x equals -1.
Okay, and then draw the vertical line.
And down.
So here's x equals -1. And using our definition, what do we know about this? The graph will never cross it because it won't equal -1.
Do you have middle markers?
Okay, they also provided you the horizontal asymptote, which we know is something that the, look at your definition, that the in behaviors approach. Sometimes you can cross it. You may or may not cross it here though. So how can I graph -1/4 though? Where would that occur? Where's -1/4? Bless you. Where's -1/4? Thank you. 4 times. Maybe 3. Where is y equals -1/4?
Below the 0.
And
1/4
above the 1. So in between 0 and 1, but is it like halfway?
No.
Less than half or more than half? Less than half. So you want to estimate about 1/4, maybe about right here? Is that about 1/4? Sure. Okay, we'll go with it. So put your dotted line here. There's HA, your horizontal asymptote, at y equals -1/4. Okay, they also provided us a hole. They said the hole will occur at x equals -3. But did they tell you the y value of that coordinate? So for the time being, we're just going to say that it's going to be -3, comma, error. Any idea why I'm going to put the word error? Because what's a hole? What is it? It's a discontinuity because it's a coordinate that got removed. So then what this is saying is at that x value, at -3, you're going to put a what here on the graph? An open circle, something that shows that that coordinate got removed. So we'll just put that there until we start graphing, and we'll fill in an open circle. Okay, so remember how we said inputs are your x values and outputs are your y values, right? Well, we need to get those coordinates from our table. So create a small table. X values are your inputs, y values are the possible outputs. Any idea why we should graph the asymptotes first though? Why would I want to see my asymptotes before I even plot points? So we know that they won't cross it. It's like a guideline. We can tell what the rational will be doing. So in my calculator, get your calculator, and you hit y equals. Go to the y equals, very top left button. Type in your function. My numerator needs parentheses, so parentheses, type in the numerator. X squared plus x minus 6. Do I put the division sign yet? No, because I have to close that first. That is all my numerator. You capped in the numerator. Divided by, open up the next parenthesis. Do I put -4 or -4 right now? When you read that to me, you say -4, which means on your calculator, be sure to actually use this negative symbol, not the minus. Okay, so we're going to put -4x squared. And then minus 16x, and then minus the 12. Close it. Once you have it in there, let's graph it to get a preview of what it's supposed to look like. So hit the top right button where it says graph. Do our asymptotes look like they're in the correct spots based off of what this looks like? Yeah, it does, right? Okay, but we still know that this is going to be separated from each other. What is going to separate these sections? Which asymptote? The vertical. Because what do we say? Vertical means that they'll never cross it. So in my table, we know that in the middle of the table, what's going to separate the sections? Say it again. Your vertical asymptote. So right here in the middle of the table, I'm going to place my vertical asymptote there. So I know that I'm going to graph both sections. Where did that vertical asymptote occur? What x value? And then what's the y value going to say if it's an asymptote? It's going to say error. And all we're going to do is we know that we're going to graph both sides of this asymptote. So we're going to pick about 3 points at least on both sides. So now go to your table where it says table in blue. Hit the second button and then table. And we're going to search for -1. Go to -1. Does it say error? Yes, because it's an asymptote. And I also want you to scroll to -3 because that -3 was our what? Our whole. So does it say error at -3? Yeah. Yes, because those are characteristics that I gave you. Okay, but I want you to list at least 3 points above and 3 points below, because that's going to graph both sides then. So above the -1, what's the one right above it? -2, -1. And we're going to ignore the whole for now because we'll come back to that when we're done graphing and just put an open circle there. So ignore the -3, move on. What's the next one? Look at it closely. -0.5, not -5. Okay, then the next one, does that look pretty? So you could use it and possibly round it, or you can use the next one. -6, comma, -0.4. I'm not telling you that you have to use these coordinates. You can pick your own coordinates. Huh?
What the hell? Jen,
Oh,
I didn't know you.
I didn't know what you said. I was gonna look for something to catch it.
Come from? Right there, look.
I wanted to catch it with something. But
Right here. Put it in here. No, put it in here then.
Catch that?
no, it just landed on her. I want it though.
Put it in here and just put something
Yeah,
on top.
just put it on her.
Can I take the sun off?
I thought like it was fine on.
Juliana, you want the soup? You want the soup?
There, I saved it. Okay. All right, now let's pick 3 points below the -1. Hello, hello. Okay, 0.5. Keep going. Thank you. Jasmine, it's for you. Next one. That one's not that pretty. You could round it, or you could move on to the next one. What's the next one? 2-0. You're leaving, Jasmine. Get your note. Okay, after 2-0, get one more. That one doesn't look that pretty. You could round or move on to the next one, which is...
For -1.
Okay, so we got at least 3 points on both sides of the asymptote, yes? So let's go graph it, and that should form some sort of curve for us to estimate what the graph will look like. So right now, let's start on the negative side. We want to graph this left section. So graphing these 3 points right here will help us anticipate what the graph will look like. So let's graph -2, comma, -1. Go to -2 on your x-axis. 1, 2. And then it says -1. So where am I going to go?
Down.
Down 1. So there's your point. -2, -1.
Got it.
Next one, we have -4 and -0.5. So go to the left 4. 1, 2, 3, 4. And where's 0.5? -0.5. Halfway down. So is it above that asymptote or below that asymptote?
Below.
It's going to be below it because a half is more than a fourth. But look, y'all notice how those coordinates are getting closer to that asymptote. They're approaching it. And look, it gets even closer. -6, comma, -0.4, which is like almost on top of it. I want y'all guys to follow my table though. What is it supposed to approach? What y value is it supposed to approach? Negative what? -0.25, is that what you said?
Yeah.
I thought you said something else, sorry. So look at the values as I go to the negatives. Everybody watching? Because we know that the x's will keep going forever, right? I'm going to just hold down this button. Look at the y's. Are they ever going to get to exactly negative 0.25?
No.
Do y'all see how they're getting really close to it though? Getting closer, closer, closer. Is it ever going to touch it though? I could keep scrolling forever. That's what I mean about going to negative infinity, but you're approaching that y value. Does that make sense? Okay, so what's going to happen over here then? It's going to go down and approach this other asymptote, but will it cross it?
No.
So then now that we have these 3 points, just anticipate what the behavior of the graph will do. We're going to curve it.
Curve.
Here we go. Curve it out.
Like I get curved.
Curve it out. There you go. You graphed the first section. Any questions?
No, man.
Okay, we're going to do the other section the exact same way. You graph the 3 points, and then you determine where the ends of the graphs will go. Okay, so 0.5. Here's 0 on the x-axis, and where's 0.5? Halfway where? Up. So here's 0.5. And then we got 2 zeros. So go to where x is 2, 1, 2. Where's 0 at?
On the line.
On the line, where I'm already at. There's 2, 0. Again, do you see the curve happening?
Yeah.
All right, then the next point we have was 4, negative 0.1. 3, 4. Is negative 0.1 below the asymptote or above it? It's going to be above it. But it got closer. So again, if I go to this table and I can prove to you guys that the further I get positive, what are these x's going to approach? They're still going to approach what asymptote? The negative 0.25. But will they get to it? Let's see. I'm going to infinity. Here we go. I'm going to infinity, but are my x's going to get to 0.25? Nope, they're just going to get closer and closer as I scroll.
That's extra.
Does that make sense though, what I mean by that now? I haven't shown you guys the values yet. I've just been saying that it will never touch it. It approaches it. Okay, so let's anticipate the ends of the graphs. This in behavior will approach the 0.25, and this will approach the what? The vertical asymptote. So curve it out. There you go. You graphed your first rational function. Questions? All right. So then there's still one thing that we left off putting on here. The hole. And where did that hole occur at? Negative 3. So go to where your x is negative 3. 1, 2, 3. And where's that hole going to be then? Right there on the blue line. So go draw an open circle right here. That was your hole. Negative 3 something. For right now, we're putting error until I show you guys how to find the y value. Okay, we're going to do one more. And if we have time, we'll do another one, but I don't think we will. Did she just go? Can I flip it? Yep. All right. Flip it. We're actually going to ignore this one for the time being because this is probably as hard as a rational we'll get to graph because they're really ugly numbers and you're going to have 2 vertical asymptotes. We'll probably save this one for Monday. But let's do this one at the bottom because it's pretty similar to the one that we just did. Okay, let's start by graphing what? Should I go straight to putting it in my calculator? What helps you graph before you do that? The characteristics. So start with your asymptotes. Where's my vertical asymptote?
Right there. 4.
What is it?
4.
X equals 4. So I go to where x is 4 and draw a vertical line. VA,
On the back.
x equals 4. Okay, they also gave us the horizontal asymptote, which is y equals 1. Go to where y is 1 and draw a horizontal asymptote. Okay, do we have any holes in here? No, so we're not going to have any removed coordinate. There are no open circles on the graph. Okay, that should be good enough. Now are we ready to go find our table? Yes. So when you're filling out your table, what did I say separates your coordinates all the time? Something you will never cross. Which one? The vertical asymptote. So right here in the middle should be your VA. And what is your VA? What x? 4. And then over here, what is your calculator going to say then? Error. Okay, you always want to base your points surrounding the asymptote. That way you know that you're graphing each section. Okay, so go to your calculator and go to y equals. I want you guys to type it in on your own, on how you think to type it in, and I'll show you what mine looks like so you can see if you did it right. That's what your graph should end up looking like if you did it right.
Oh yeah.
I've got it. Yes, I do it differently, like the alpha and the for the fraction.
Some of them has it, some of them don't.
But this is like the different way, it doesn't have it.
Yes. Like if some of the calculators are updated and you can do that with it.
You have to update these.
Yeah, these are old. If they have the updated part, it like puts the fraction bar for you, and you don't have to use the parentheses then, because then you have numerator denominator. The calculator knows it. The parentheses otherwise is when you can't actually put the fraction bar, you're writing it as division, then you gotta say it.
We gotta update.
Yeah, the calculators would have to be updated. Not all of them in here do it, so I'm just showing them this way just to do it. All right, everybody got this? Okay, so let's go to the table. Second table, go find your vertical asymptote at 4. By the way, how many of you ever go to your calculator and then you see this crazy stuff and you sit there and you scroll to 0?
Me.
Yeah.
Have you had a teacher show you how to get to 0 faster?
Oh my god, I forgot.
What are you trying to do? You're trying to set the table at a value, right? Where does it say table set? Right there in blue. So hit the blue button, table set. What do you want it to start at? Well, we want it to go to what? 4. So I'm going to hit 4. Go back to your table, second table. Bam, you're at 4.
What the hell?
Language.
Where was it?
When did?
Okay, where
I
it says
never
table
did that.
set. Table set,
Oh, got it.
where you're setting your table. So go to blue, table set, and then you start the value at whatever you want. So we wanted it to start at 4. I go to 4. Your table starts at 4. You don't have to sit there scrolling.
When did we learn that?
You've learned it, I'm sure. All right, and how many points minimum do we want to be able to figure it out? 3. So go above. 3.
-1.
2, 0.
Okay, above again. That's pretty. 2, 0. Above again. Is that pretty?
No.
You could estimate or go again. That one works. 0.5. Okay, now we want 3 points below the asymptote. So on the opposite side, 5.3, 6.2, and 1.5. Thank you. All right, question on finding your coordinates. Okay, so it's handy to keep the picture here. That way you know where they should be at, right? So we have this bottom left section, which is the negative side, and we have this top right section, which is the positive side. So let's graph the left side first. We have 3, -1. Go to where x is 3. 1, 2, 3. Where's -1? Down. Now graph 2, 0. Go to where your x is 2. 1, 2. Where's 0? Where I'm at. And then 0.5. Go to where x is 0. Where's 0.5? Halfway up. Okay, do you see the curve happening? So we know that as it goes this way, what is it the y supposed to approach?
Horizontal line.
It's supposed to approach that HA, the 1. So extend it out, approaching the 1. Will you cross it right here?
I'm not even grabbing this. I'm not paying attention. I was paying attention, but I wasn't like.
Okay, and then where's this side going to go?
Down.
Down towards the
Vertical.
vertical asymptote. There you go. You graphed the first section. Now we want to graph the other section. So 5.3. Go to where x is 5. 1, 2, 3, 4, 5. And we go up 3. Then we have 6.2. Go right 6. 1, 2, 3, 4, 5, 6. Up 2. There we go. We see the curve forming. And then 8, 1.5, which is halfway above the 1. So right there. There's your curve. And again, extend your behaviors going towards the asymptotes. They are approaching them. What's up?
I wasn't even looking at you, so I looked at the board. She said, Kira or something else.
I don't even know what y'all are talking about.
I looked over. She just doing something weird with her feet.
Oh. Do we have any open circles anywhere?
No.
Nope, because there were no holes. So we're done.
Yay.
No holes here.
Okay. The only thing I want to do is form the table. We won't graph this one, okay? We're just going to form the table as if we were going to graph it.
No.
Because this one looks really weird.
That's too much vertical.
Okay, how many vertical asymptotes do we have this time?
2.
2. We graph both of them then. X equals -3 is right here. And the next one's at x equals 2, so right here. How do I graph y equals 0? Where is it on though? So this is y equals 0? It's on top of the x-axis. So the HA is your x-axis right now. This is y equals 0. That's your horizontal asymptote. Y equals 0. Do we have any holes?
No.
No, so we're not going to have any open circles anywhere. Okay, my question is if I have 2 vertical asymptotes, how many sections of the graph will we see?
2.
What?
3. What?
3.
Why 3?
Because there's going to be a middle section.
Yeah, there's going to be that middle section now. So then in my table, is it just going to be 3 points above, 3 points below? No, because you're going to have 2 vertical asymptotes. So watch how we form our table. It's going to be a little longer. Okay, so in the middle of the first section should be your first vertical asymptote, which is what? -3, and then the calculator will say error. And then you're going to get 3 points above, 3 points below, but then what happens? Then you have the other VA, which is 2, error. And again, you'll already have the 3 points above, but you'll have to get the 3 points below. So the VAs will always separate your sections because you know that you won't cross them. Okay, go ahead and go into your calculator, type it in. Don't second guess yourself, type it in, and then I'll show you mine to see if you're correct.
No.
Don't you second guess yourself, I said.
These numbers.
I said, don't second guess yourself. It's fractions. You're gonna get ugly decimals,
I
guys.
know you're lying.
Okay, stop. First of all, did you go to the graph? Because I said go to the graph first.
Yes, I did. Look at my
Does it look like that?
Yeah.
Okay, if it doesn't look like that, you typed it in wrong.
Why does it look like that? Oh, because it's like small.
It's really, really, really close to the asymptotes.
This looks ugly.
Now, let me show you why. When we go to the table, look at those decimals.
Oh, heck.
How close are those decimals to 0? Really close. I wonder why. What's our HA?
0. Mind blown.
Oh.
Okay, is that, don't freak out, because you know what? We're going to round them. And even though they're really ugly numbers, we can still deal with it. So let's go to that -3 the same way. Like I said, we're just going to form the table right now. I doubt we'll have time to grab. So go to -3.
I'm gonna choke on my water.
Does say error.
Mm-hmm.
Go to 2. Does say error.
Yeah.
Then we know that we're using the correct coordinates.
God, it's ugly.
All right, so let's go above. They're all ugly. Do we have any pretty ones?
No.
Then we have no choice but to use these, but it's okay. We're going to round them,
Oh.
right? We'll round them to make it easier on us. So here we go. Next one, -4. And if you round that to the second decimal spot, what would it be?
5.3.
Second decimal spot.
0.5.
0.06. Thank you. Then go up again, -5, and round this one to the second. Point 02. And then the next one. See how those are really getting close to 0?
Yeah.
Yup. They're hugging the asymptotes really tightly. Okay, now go below the -3. We're going to do the same thing. -0.08. Gosh, Gage.
It's not working. Look at his
Okay, I want y'all to look at this though. Do y'all see how these are practically the same value that the calculator is giving you?
Yeah.
So are you going to write it again?
No.
Let's skip that one, go to one that changes. So what's this one? 1, comma, negative 0.08. Alright, you're good. Okay, we got 3 more points. Go to the 2.
Wait, there's 2 points on
Yes, and you'll see why. Because it's going to dip. Remember, sometimes in the middle, we can have a different shape. Alright, so below the 2, what do we have?
Let's see. 0.06.
0.06, 4,
0.02.
and the last one.
0.01.
Okay, we got it?
That's a pretty graph.
Ooh, I do have enough time to graph it. Yay!
No, we don't.
Okay, guys, it's okay. I just want to finish it. Okay, we ready? Let's start with the negatives. Negative 6, negative 0.01. That's really close to 0, isn't it? Okay, so let's put it practically on the 0 then. Next one, negative 5.02. Just a little bit above it. Next one, negative 4.06. A little bit more above it. So what is it doing? It's practically on top of 0, but is it increasing or decreasing? So am I going up or down towards the asymptote? Up. There you go. So hug them.
Woo,
There you go. You graphed it.
I don't know why I said that.
All right, next part.
Oh my goodness.
Now we're in the middle section, right? We're on the opposite side of the VA. So go to negative 2, negative 0.08. So here's negative 2. Where's negative 0.08? Just a tad bit below. Okay, negative 1, negative 0.06. Is that above or below the 0.08?
Above.
It's a little bit above it. And then look what happens at 1. What does it do though? What do y'all notice here?
It's gonna be like this.
Look at these numbers, guys.
She gotta go.
They're the same. So it goes up, but then it comes right back down to the same value. So what is this doing? What are both sides going to do now? They're going to curve which way? Down. So think of this middle section as like a parabola. Girls, come on. We're almost done. All right, last section. Gage, nobody said for you to pack.
I'll just put in this calculator.
Sit. 3.06. Little bit above. 4.02. Even closer to 0. 5.01. Even closer to 0. So look, we're hugging very tightly. And again, hugging very tightly. But isn't that what your calculator looked like?
Yeah.
This is as ugly as it's going to get, guys. I don't even think I'll even give you one like that. Okay, these are the ones that we'll stick to mostly. Okay, go ahead and pack, even though Nicole can't bear her laughing right now.